There are three main points that I might highlight regarding how the syllabus structure has changed. The first and most obvious one is that all topics and subtopics are now categorised under two broad overarching themes, which are structure and reactivity. The idea being that there's a conceptual relationship between these two themes. Structure determines reactivity, which in turn transforms structure. The second point to highlight is that essential ideas in the current course have been replaced by guiding questions for each subtopic, which frame the learning in each particular subtopic and also provide a bit of a broader scope for exploration for how we plan and structure the course. The third point to mention is you'll find linking questions in each subtopic which make reference to skills, the nature of science, and understandings from other subtopics. There's been a considerable reduction in terms of the content in the new course, and the majority of this comes from the removal of the optional topics. It's worth noting, however, that some specific points from different optional topics have now been integrated into the new course. For example, polymers, fuels, ocean acidification, chromatography, to name just a few of them. In terms of other changes from the current content, there are a few minor edits. For example, Lewis structures are now called Lewis formulas, and you won't see the EZ classification of organic compounds anymore. But apart from that, most of the content is pretty similar. It's probably also worth noting that there's a bit more of an emphasis on skills in the new course, and these skills are categorised under tools and the inquiry process, and you'll find explicit connections to those in the linking questions in each subtopic. The new course has been designed to offer a little bit more flexibility and freedom in terms of planning pathways through the course. So now, instead of topics 1 to 21, we have our topics organised under two overarching themes, which are structure and reactivity. So in thinking about how to plan these pathways, I think there's probably three main considerations. First of all, of course, we want to build a logical progression of knowledge as we move through the course. Secondly, we might want to identify particular subtopics or understandings that warrant coverage before the internal assessment, now called the scientific investigation. So things like rates of reaction, stoichiometry tend to appear pretty commonly in the IA. And thirdly, it might depend a little bit on whether you teach separate standard level and higher level classes or perhaps a combined group. So on balance, taking these different factors into account, I would imagine that most teachers will probably start with Structure 1 and Structure 2 at the beginning of the course, and then perhaps prioritise subtopics from reactivity, so 1.1, 1.2 and 2.2, which cover things like stoichiometry, energy changes and rates of reaction, because these are kind of particularly common topics that appear in the internal assessment.